Good morning, AFM students. This is Miss Brown. Today and tomorrow we're going to be in the first section of Chapter 8, talking about the unit circle. So I want to give you a few notes and go through a couple of examples with you that you will use for your assignment for both today and tomorrow. First of all, I want to remind you about the quadrants when you have a coordinate plane. We know that the quadrants will rotate counterclockwise. We have our first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. So when we have a circle here, basically the unit circle is centered at 0, 0, and the radius of the unit circle is the number 1. So when you have points that fall on the unit circle, I want you to remember that any point that falls within quadrant number 1 has a positive x and a positive y. Remember, when you're graphing points, you go either right or left on the x-axis, and of course you go up or down. So any point that falls in quadrant number 1 is going to have a positive x and a positive y coordinate. Now, as you rotate over to this side, any point on the unit circle that ends up in quadrant 2 is going to have a negative x with a positive y coordinate. In quadrant 3, any point that falls in the unit circle down here is going to have a negative x and a negative y for their coordinates. And quadrant 4 will have a positive x but a negative y. So some of your questions today are asking you about where the point falls in your unit circle, which quadrant it is on. Now, of course, you also have points that could fall on the x-axis or the y-axis, or you could have your terminal point be somewhere inside of your quadrants. Now, the first thing we want to talk about is the equation of the unit circle. This is found on page 507 in your book. It's a very easy equation because it's just x squared plus y squared equals 1. You may recall the equation of the circle that we normally have is equal to the radius squared. But since the radius of the unit circle is always exactly 1, then 1 squared is just 1. So again, when we look at this, the unit circle is centered at 0, 0, and it has a radius of 1. That means that this point would be the point 1, 0. If I came straight up, this would be the point 0, 1. If I go out to this side here, that would be the point negative 1, 0. And then down here would be the point 0, negative 1. Remember, the radius of the unit circle, no matter where you draw that from the center, is going to be a length of 1. So the very first example that we have wants us to show that this point right here is on the unit circle. Now, obviously, it has a positive x and a positive y coordinate, so we're thinking this point should be somewhere in the first quadrant, and we want to prove that this point, that this x coordinate and that y coordinate actually falls on the unit circle. So what I'm going to do is just plug in those coordinates and see if this works itself out. Okay, so if I plug in the x coordinate into the x and that y coordinate into the y, I'm going to have the square root of 3 over 3, quantity squared, plus the square root of 2 over the square root of 3, quantity squared, and I want to prove that this actually equals 1. Now, when I square this, a square and a square root are going to cancel, so my numerator is just 3. 3 squared is 9. For here, the square root and the square will cancel on the top and the bottom. So basically, I have 3/9 plus 2/3 is supposed to equal 1. I just reduce that fraction down. 1/3 plus 2/3 ends up being 3/3, which actually is 1. So I have just verified that this is a coordinate that is on my unit circle because it works when I plug it into the equation. Okay, so this is example 1, and you're going to have a few problems like this on homework. Now let's look at example 2. Example 2 tells us that point P is on the unit circle, but it only gives us the x coordinate. We have to solve to find the y coordinate. Okay, now I also want to point out in example number 2, they tell you that the point is supposed to be down here in the fourth quadrant. So the x coordinate is going to be positive, but I'm looking for a negative y coordinate. In order for this point to be in the fourth quadrant, I have to have a negative y coordinate. So when I plug these numbers into my equation, I'm going to square the x, it's the x squared, plus the y squared equals 1. So when I square this fraction here, I end up with 3/4. I'm going to subtract 3/4 to the other side. So 1 subtract 3/4 leaves me with 1/4. Then when I take the square root of both sides, to get rid of the square, we take the square root. Now normally we would slap down the plus and the minus, so we have a positive and a negative 1/2. But remember, we're interested in the fourth quadrant, so I really want the negative y coordinate. So if you have to find a missing coordinate on the unit circle, use that equation and just plug in the numbers to solve. Okay? You will also find on your Delta Math that I have attached a picture of the unit circle. Now, some of the questions for today's assignment is going to ask you about the location of that terminal point. So, guys, the terminal point is just the coordinates that go with this particular point on your unit circle. Now, if you'll look at your diagram that I've provided for you, you can see that some of these are in degree mode and some of them are in radians. We talked last week about how to convert from degrees to radians, so I want you to notice if we start right here at 0 degrees, we can work our way up 30 degrees, 45, 60, 90. It goes all the way around to 180, all the way around to 270, and once you do a complete revolution, you're back at 360 degrees, which is the same starting point that we were before. Now, you also have your radians. 30 degrees is the same thing as pi/6 radians. Remember how we said that 180 degrees is the same thing as pi. So if you look at some of the other examples that are in the book, okay, in example number 3, it wants us to find where the terminal points are on this unit circle. So here in example 3a, it wants us to find the coordinates where the terminal point is at 3 pi. So refer to your diagram. If I come all the way around here, that's 1 pi. Another 180 degrees would be 2 pi, which means another 180 degrees would be back at 3 pi again. So 3 pi is the same thing as one full revolution plus another semicircle. So 3 pi is in the exact same spot as pi, and you can just look at the coordinates right there. Your answer for 3a is going to be the coordinates at -1, 0. That's the location of where 3 pi falls on your unit circle. All right, look at example 3b. They want you to say, where is the point, the terminal point, at -pi? Now, when we're doing negative angles, if we rotate around counterclockwise, that's positive angles. So all you have to do to get negative angles is rotate in the reverse direction. So negative pi is the same thing as rotating in the negative direction pi. Okay, so 180 degrees in the opposite rotation is still going to put your point right over here. So the ordered pair is going to be at -1, 0. Okay, the last example that I want to show you is where your terminal point is going to fall at -pi/2. Now, if you look at this unit circle, okay, pi/2 is the same thing as a 90-degree rotation. Degrees is 90. If it's in radians, it's in pi/2. So if I were just going to rotate 90 degrees up, this would be the location at a positive pi/2. But they wanted us to find the point at -pi/2. So instead of rotating 90 degrees this way, we're doing -90 degrees, which means we rotate this direction. So the location of a negative pi is the same thing as -90 degrees, which is going to be right here, and that ordered pair is going to be at 0, -1. So remember, if you've got a positive angle, you're going to rotate around counterclockwise this way, just like the quadrants go. Quadrant 1, 2, 3, 4. But if you have a negative angle, that just means you're rotating the opposite direction and you're rotating clockwise. Okay? I have 6 problems that I want you to try tonight, and you have 4 that I want you to try tomorrow from this same section. And again, the great thing about these videos is you can always pause, take some notes, look at the examples from the book. Let me know if you have any questions. Good luck.